Alrighty, so we talked about angles, so the natural progression would be to talk about triangles next. So we're going to be talking about the Pythagorean theorem. You may have seen this before. If so, this is a review. If not, this is good new stuff. So what I want you to do first is I want you to watch this video on what the Pythagorean theorem is and how it works. I'll include a link in the description and in like a pop-up annotation thing. Alright, so assuming that you've paused it and watched it, we'll talk about what the Pythagorean theorem is. What it is a thing that works only for right triangles. So if it's a right triangle, typically we will have a little square in the corner telling you that it's a right triangle. Now, if you have a right triangle, we use special words for the sides of the triangle. The two shorter sides, they're kind of meh, nothing special. We call them legs. So that's this guy and this guy. The longer one is special. We have a special name for it. We call that the hypotenuse. I'll try to write that neater. Hypotenuse. Right, that's this guy. So make sure that you know the different sides of the right triangle. The hypotenuse is always the longest side, and it's always across from the right angle. Right, so you'll see the right angle's there, it's always across from it. Across from the 90-degree angle. Alrighty. So when we're using the Pythagorean theorem, the formula for it is a squared plus b squared equals c squared. So in order for this formula to work, the hypotenuse always has to be side C. The legs can be A and B, and it doesn't matter which one is which, as long as the hypotenuse is always C. Okay? That guy is always the hypotenuse. Okay. You will have this formula, but you'll be using it so much that you will have it memorized. Alright, let's talk about using it. So, things you can do with it. Thing number one. If you know two side lengths, you can find the third. Right. If you know three sides of a triangle, what you can do with it is you can find out if it's a right triangle. All right, so you can determine if it's right. Right triangle. All right, and I'll do examples of all of that. So first, finding the missing side. So in this case, sorry, there should have been a little square there telling you that it's a right triangle. And we should start by labeling this triangle. So we can see that across from it is this side here, the question mark one. That means this is the hypotenuse. Which means when we're labeling it, this has to be side C. And the other ones can be A or B. All right, so for this example, we are looking for hypotenuse. Or the hypotenuse, if we want to use good English. All right, so first thing we do when using Pythagorean theorem is we write down the formula. A squared plus b squared equals c squared. So once you have the formula written down, you are going to sub in the numbers into the right spot. All right, so A was 6. So instead of A, we're going to write 6. And don't forget the squared. That's still there. B was 8. And C, we still don't know. make sure you keep those squareds there. Second step is to get rid of the squareds. So 6 squared is, well, we can do two things. If you go to your calculator, some of you will have a squared button. My Google calculator doesn't. So what I can do is 6 and then the x to the y button to the power of 2. Right? So I know 6 squared is 36. Now, squaring it, the exponent is repeated multiplication. All right, so I'm going to redo 6 squared here in case you don't trust me or believe me. Right, so instead of 6 squared, if you're using just like your normal iPhone calculator, you can just go 6 times 6. So 6 times itself twice. Okay, that's what the 2 means, times itself twice. If it was a 3, it would be times itself 3 times. Alrighty, so for 8 squared, 8 times 8 is 64. And we're still looking for c squared. Now I'm going to do that addition, 36 plus 64. So that equals 100. Equals c squared. But we're not done yet. See, that's what c squared equals. I want c by itself. So in order to get c by itself, I need to undo that square root. So to do the opposite of a square root, to get rid of it, to do the opposite of a square, we square root it. But whatever you do to one side, you gotta do to the other. So on the c side here, the square root and the square cancel out, and all you're left with is c. Equals the square root of whatever your number was. In this case, 100. So now I have to take the square root of 100. Okay. So I can go to my calculator, square root of 100 is 10. C equals 10. And because these were both meters, this is also meters. And that's my answer. So that's finding the hypotenuse. Let's see, is it any different if you're looking for a leg? So I've got another right triangle here. We're going to quickly label it. So across from the right angle, the longest side. This is the hypotenuse, so it has to be C. And these other ones can be A and B. So I'm going to start off with the same steps. First step was to write down my formula. Squared plus B squared equals C squared. Alright, so now that we have the formula written down, you just have to sub the numbers into the formula in the right spot. So A was 5, so we have 5 squared plus B, we don't know, so we'll leave that as B. And C was 13. Don't forget your squareds. Alright, so now we're going to simplify the numbers we know. So 5 squared, or 5 times 5, is just 25. B, we don't know, so leave it as B. And don't forget the squared. And 13 squared, 13 times 13 is 169. So now we have this one new step. We're, trying to work backwards into getting B by itself. So we need to undo this addition. The opposite of addition would be subtraction. So we're going to subtract the number that's in the way. So that's 25. Now whatever you do to one side, you do to the other. 25 minus 25 is 0. So we're just going to have B squared equals 169 minus 25. 169 minus 25 is 144. Now, that's not our answer yet. That's just what B squared equals. Remember, we need to get that B by itself. So to undo the squaring, we take the square root. And whatever you do to one side, you do to the other. The squared and the square root cancel out, and all you have left with is B is the square root of 144. And the square root of 144, the square root of 144, is 12. Is 12. And because these two numbers were in meters, my answer is also in meters. Alrighty. One last example. Is the following a right triangle? I know my 3 sides. It looks like a right triangle, but I don't know. It doesn't have that little square there, so we don't know if it's a right triangle. Now, the Pythagorean theorem only works if it's a right triangle. So, if we put all these numbers into the Pythagorean theorem, into that formula, and the left side and the right side end up being equal, then it works. So first thing we're going to do is write down the formula. A squared plus b squared equals c squared. Actually, I lied. That should be the second thing we do. First thing we do should be to label this triangle. So this is the longest side, and if it is a right triangle, this would be the hypotenuse. And the two legs are a and b. So now we write down the formula, which we did, and we're going to sub the numbers in. So a, we said, was 7, plus b was 4, and we were trying to see if that equals 9 squared. So because we don't know if this is actually equal, I'm going to put a little question mark there. That's what we're trying to figure out, if it's equal. So we're going to do the exact same thing we've been normally doing. We're going to simplify what we know. All right, 7 squared, 7 times 7, I'm going to do these ones in my head, is 49. 4 squared, that's 4 times 4, is 16. And 9 squared, that's 9 times 9, is 81. Right, now I just have to do my 49 plus 16. So 49 plus 16 is 65. So I don't know, does 65 equal 81? No, absolutely not. They're different numbers. No! Right? 65 and 81 are not the same. 65 does not equal 81. So because they're not equal, it's not a right triangle. It is not a right triangle. If they turned out to be the same number, then yes. So it is not a right triangle. Alrighty. So try these practice questions. Ask me if you have questions. Have fun.